Thank you, Marcus, and thank you all so much for coming. This is quite the turnout for a logic talk. I hope I can make it worth your while. It will definitely be worth my while because I'm very excited about this work, and after Julian Schlöder's talk here, who hyped me up a little bit, I really can't wait to tell you all about it. So just the usual advertisement at the beginning. This is a joint work with Luca Incurvati from Amsterdam. This is in fact like a long shot left over from my dissertation under his supervision. And these parts that have now crystallized in our minds will be part of our upcoming book called Reasoning with Attitude. It was supposed to be in press by now. It is not, because we have to do one more proofread, I think. But then it's out, I hope. But I hope to have some news there too. And this is one part of this book I'm very excited about. So let's go in. So there's a tradition in truth research called, under different names, Deflationism, Pragmatism, Minimalism. And they begin with a very interesting claim, namely the claim that the truth predicate has a certain raison d'etre. It fulfills certain needs, it has a certain function. And some of these functions, so I think these are Crispin Wright's terms, are indirect endorsement, compendious endorsement, and infinitary endorsement. So a kind of indirect endorsement is when you say what Frege said about meaning is true. And yeah, I can say that without really knowing what exactly it is that Frege said about meaning, because perhaps I forgot what he said, or perhaps I don't quite understand what he said, but I'm pretty sure that what he said is true. So without the truth predicate, I would have no way at all to make such a claim about what Frege said about meaning. So that's one of the needs that the truth predicate satisfies. Another need that it might satisfy is this compendious endorsement. I might say everything Aristotle said is true. And if I would have to list every single thing that Aristotle said and asserted, it would be very tedious. I would not be a very pleasant conversational partner. But I can just compactly say everything Aristotle said is true, and thereby show my philosophical colors, if you will. And it might even be impossible for me to make all of these individual assertions, because I might even include undiscovered or totally lost works. And I'm so sure of my belief in Aristotle that I say everything in there is also true. And finally, for us logicians, there's the sentences like, all sentences of the form P and not P are true. Maybe you want to assert this if you're a nihilist, the truth nihilist. And there's a point to this, because there's infinitely many sentences. You can't assert all the individual instances of the principle of contradiction. So if you want to say that all contradictions are true, then you have to use the truth predicate to be able to do that. And so all of these are useful things to have in a language, and we need the truth predicate for them. And according to deflationism about truth, this is why we have the truth predicate. This is the reason for the truth predicate being in our languages. And then they take a step further. So according to deflationism, then what the truth predicate really is nothing more than a device to meet these needs. These needs, to fulfill this need, is the function of truth, and truth should therefore be characterized with the minimum amount of assumptions required to fulfill this function. And you may now think here there's a kind of philosophical razor at work, something Ockhamish-ish happening. And yes, there is, and I will go more into that part in my Brownback talk in a few weeks. But for now, let's continue on. Let's take this for granted as a methodological principle and plow onwards to truth. And so, of course, mathematics, I mean, or wonderful logical theories, they can imagine other things that would fulfill this need, that would satisfy this function. For example, substitutional quantification or infinite disjunction, all of these nice things we have discovered. But in a very obvious way, the needs of indirect, compendious, and infinitary endorsement are met in our actual language by the truth predicate. Yeah, let's shout out to Ruth, Bark, and Marcus. Okay, and now I want to compare this with a story, thank you, Louis, with a story on negation. Also many shout outs to be made here, but I'll just give you the rundown. If you think about negation in a particular way, it also has a certain raison d'etre. It fulfills certain needs. And that need is pointed out by Hugh Price recently and many, many others before him, is that the need for negation is to express rejection. So to pointing out to somebody that two things cannot be the case simultaneously. And so there's very fanciful stories you can tell about this need, but just you may imagine living in a linguistic community without such a device, and then somebody claims P, and perhaps you find P abhorrent. You want to contradict them, and what can you do without negation? Well, you can assert a contrary statement, Q. But what if they don't understand that these two are contrary? Maybe this contrariness is very difficult to see, and they just say, oh, it's P and Q, thank you, I learned something. And maybe you can sit them down and say, okay, let me introduce this mathematical operator this like little chunky negation operator, and then show them the truth table for negation, and this is what I mean. But then we have to teach them about the incompatibility between truth and falsity, the incompatibility between the 1 and the 0 and the truth table. And how are you going to teach somebody about an incompatibility if you have no device to express incompatibility? And so according to Hugh Price, that's what negation is for. It's the device for communicating incompatibilities. And this leads to a kind of pragmatism about negation. So Price's conclusion is you need something with a basic meaning, I am registering an incompatibility. And he concludes from this maxim that what negation really is the expression of rejection. And this has a very rich pragmatist history. So this goes back to claims made by Peirce and Ramsey and Sellers, among many others. I've written a more modern, more normative take on the same matter recently. But the first very clear expression of such a view is perhaps found in Frank Ramsey's Facts and Propositions, where he says, my theory holds that the significant of not consists not in a meaning relation to an object, so not a truth function, or like denotation or anything, but in an equivalence between disbelieving P and believing not P. And so what Ramsey seems to be saying here, I don't want to put too many words into his mouth, is that we intuitively, or before we engage in kind of linguistic discourse, we appreciate an incompatibility between believing and disbelieving, or believing and doubting, or something like this. And negation is what allows us to negotiate this incompatibility in our languages, or then even in our beliefs as well. But being a pragmatist, he thinks that believing comes after language. Okay, so that's pragmatism about negation. And you might see that there are many similarities between what these pragmatists are saying about negation and what these deflationists have been saying about truth. And I think these similarities are a little bit underexplored, so we're going to be exploring them today. Now, of course, in this group in particular, we know that Frege in Die Verneinung had a big problem with this kind of Ramseyan approach to negation. He published this even before Ramsey, and Ramsey just didn't care. So Frege points out very incisively that negation can embed in more complex sentences, and in some of these embedding, you don't express rejection. And Frege's example, slightly shortened, is the following. If the accused was not in Berlin, then he did not commit the murder. And to say that is not to reject that the accused was in Berlin. You can very much be in a state of believing that the accused was in Berlin. You can still intelligibly utter this conditional. If he was not in Berlin, he did not commit the murder. And then Frege puts his finger on this issue and says, puts pressure on the issue and says, what does not mean here if otherwise it is supposed to be used to express negation? If we say that the bare assertion, the accused was not in Berlin, is expressing rejection, then what is that sentence doing embedded in this conditional where no rejection is expressed? And so this problem sat a bit dormant for a while until Peter Geach picked it up. And so now it is known as the Frege-Geach problem for the rejectivist analysis of negation. And Geach, fanciful as he is, concluded that rejection is a futile complication that cometh of evil. And this is a bit of an interesting turn of phrase, and I dug a little bit into Geach's Frege commentary. And as a matter of fact, he thinks that Frege is making an allusion to the Gospel of Matthew here, where there's a quote, "Let what you say be only yes and no, everything else cometh of evil." So Geach is appropriating this phrase here. For the record, in my reading of the German Frege, I can't find any such allusion, but it's a funny turn of phrase that Geach adopts here. Anyway, so that's the Frege-Geach problem. What would it mean in embedded context if it's supposed to embed rejection? And this is a very significant problem for these Pricean, Ramseyan, Selarsian accounts of negation. And so back to truth, and it turns out the deflationists, without calling it a Frege or a Geach problem, have found the same problem by themselves independently. So here's a similar problem for deflationism about truth. So if you recall that the claim was that the truth predicate is to be explained by its function to express endorsement, but then we can express sentences like this. If what Frege said is true, I should stop here. If Frege is right, there's nothing for me to do. But this can be asserted without endorsing what Frege says. And indeed, me giving this talk right now, I can say what Frege said is true, I should stop here. If what Frege said is true, I should stop here, but I am not endorsing that what Frege said is true. But then what does is true mean if otherwise it's supposed to be used to express endorsement? So if I say what Frege says is true, is supposed to be endorsing what Frege said, but then when I form this conditional, I'm not making such an endorsement. This is a problem for deflationism about truth, has been noted in the literature, and it is clearly the Frege-Geach problem, but it has never been discussed in terms of the Frege-Geach problem. They just chanced upon it independently and have not made this connection yet. And so I think with the situation, there are some very, very deep similarities here that are worth exploring. So pragmatists claim that negation is to be explained by the expression of rejection. Deflationists claim that truth is to be explained by the expression of endorsement. Both face Frege-Geach. In both communities, it's acknowledged that you have to do something slightly different to solve Frege-Geach. And I will just put these both together and give you like one unified approach to solve them both, which I'm going to be calling pragmatism about negation and truth for lack of a better term. And the formal explication of this kind of pragmatism is called bilateralism, and I will have to spend a little bit of time getting us all up to speed with what that actually is. And I have to assume without much more argument that we are going to be giving meanings in terms of inferences. I justify this elsewhere at length, but for now you have to believe me. So inferentialism is the claim that the semantic value of an expression is given by how a sentence containing the expression may be used in inferences in virtue of containing that expression. And that is a big mouthful, but it's really quite straightforward. So the following natural deduction rules represent the meaning of conjunction. So a sentence containing a negation is used in inferences in virtue of containing a sentence containing a conjunction is used in inferences in virtue of containing a conjunction according to the following rules. If you have two sentences A and B, you're allowed to infer A and B. If you have a sentence A and B, you're allowed to infer A. If you have a sentence A and B, you're allowed to infer B. That's the meaning of conjunction. And as a tiny historical note that I also go into at length elsewhere, this is the true expression of Frege's context principle. So Frege in the Grundlagen claimed you should only search for the meaning of an expression in the context of a sentence. And I want to note that referentialist semantics, where you put double brackets around predicates and around conjunctions and around names and so on, they are not doing that. And this is a perfectly compositional way of doing meaning, taking seriously the context principle. And so as Dummett has argued in his Frege commentary, this is probably what, I mean, he's not saying this, he's saying this is what Frege meant. I don't believe that, but I think this is the truest expression of the Fregean thought about meaning here. Anyway, moving on. So just everything I will do in terms of meaning will be given in terms of inference rules. And this leads us to the idea of bilateralism. So Frege originally based logic on what is asserted. And again, a historical note, this little turnstile we use for inferences is originally a signifier for assertion in the Begriffsschrift. But to implement the pragmatist insight that negation is supposed to be expressing rejection, we must contenance both assertion and rejection in our meaning conferring logic. And so Ian Rumford in 2000 has shown how to do that. So he uses plus as a sign for assertion and minus as a sign for rejection, so we can keep the turnstile in its modern use. And then Rumford gives the following meaning for conjunction. So he has the received rules just prefixed with plus. So from the assertion that A and the assertion that B, you get the assertion that A and B. From the assertion that A and B, you get A. And from the assertion that A and B, you get the assertion that B. But now we complement this with rules for rejected sentences. And so if you reject a sentence A, then you are entitled to also reject the sentence A and B. If you reject a sentence B, you're also entitled to reject the sentence A and B. And then the last was like disjunction elimination. So if you have rejected A and B, that roughly means that one of the two is to be rejected. So if you reject a conjunction, you're rejecting either conjunct. So then if you have the rejection of A and B, and you have the rejection of A entailing some other sentence phi, and the rejection of B entailing some other sentence phi, then you get to infer phi. And so Rumford says, this is how then a bilateral inferentialist meaning of conjunction is to be gotten off the ground. And if we are okay with that, and I'm going to assume that we all are, then you can give a very, very straightforward implementation of this pragmatist negation. In fact, literally just implementing Ramsey's suggestion. Because we can now say that the meaning of negation is that it permits inferences between assertion and rejection. So from the rejection of A, you get the assertion of the negative. From the assertion of the negative, you get the rejection. From the assertion, you get the rejection of the negative. And from the rejection of the negative, you get the assertion. And by doing this, we have successfully skirted the Frege problem, because rejections themselves, they are not embedding, so we can't even get the Frege argument off the ground. And now the embeddable negation is not itself directly expressing anything, but it has an inferentialist meaning in terms of what it contributes to a complex sentence, and that kind of meaning can, of course, embed. And to spell this out a bit, so negation makes a contribution to how we can infer with a complex sentence containing a negation. And that validates all kinds of inferences for embedded negation. So for example, if you have the assertion of if not A, then not B, and the rejection of A, you can derive the rejection of B if you have modus ponens. So in Frege's example, if he was not in Berlin, he did not commit the murder. You assert that, and then you reject that he was in Berlin, you are entitled to infer that you reject that he committed the murder. And this is all perfectly fine. So the Frege problem is avoided this way. However, in doing so, we might have implemented the surface level of the Ramsey price suggestion, but nothing that we have done so far ensures that negation can be used to register incompatibility. So remember that in Price, we had this as the basic function of rejection, and in Ramsey, we had this basic incompatibility between belief and disbelief. So we need to encode this incompatibility somehow. And Timothy Smiley in 1996 made the right suggestion here, namely that we have distinct inference rules governing the coordination of the two speech acts, assertion and rejection. And so the following rules are called Smiley reductio, and they have it that asserting A and rejecting A is incompatible. You get an absurdity from there. And moreover, they are contraries in the Aristotelian sense. So from the assertion of A, if that entails an absurdity, you are entitled to reject A. And if from assuming that you are entitled to reject A, you get an absurdity, you are entitled to assert A. And that completes the pragmatist picture. We have now the basic incompatibility of assertion and rejection. And we have an account of negation that says negation is used to reject. So we have the pragmatist insight. But there is a problem with this, a big problem, but it will actually turn out to help us. Inferentialists in the tradition of Michael Dummett and Doug Pravitz, they usually presume that inference preserves evidence. And well, the broad view is that atoms are carriers of evidence, and the rules state how to pack and unpack these into more complex claims. So here's a suggestive quote by Doug Pravitz from a recent paper. Assertions are evaluated, among other things, with respect to the evidence the speakers have for making them. We may also say that the aim of inferences is to make assertions justified. That is, if you read that, evidence is what justifies assertions and is preserved in legitimate inference. And indeed, there's a whiff of pragmatism about inference in there. According to Doug Pravitz, you could read it as that the purpose of inference is to justify claim. So just inference is the thing that has the property of preserving the thing that justifies assertions, so evidence. However, Imogen Dickey noted that this just does not jive with Rumfit style bilateralism at all, because a sentence may be rejected not just for evidence for its falsity, but also for entirely different reasons. So here's the first example on this slide is by Dickey. Is it the case that Homer wrote the Iliad? You can reject this as no, Homer did not exist. But this is not evidence for Homer did not write the Iliad. And here's an example by Paul Grice. Is it the case that X will win the election? No, X or Y will win the election. And so again, to say no, X or Y is not to say not X. And so these are what we call weak rejections. They are rejections not justified by evidence for the negation of the sentence they reject. And so Dickey concludes that rejection cometh of evil after all, because it cannot feature in evidence-preserving inference. But there is a way to resist this observation. So first, we might begin to insist that when we talk about rejection in these bilateral terms, we only mean the strong rejections. We only mean those that are justifiable by evidence for their negation. But Dickey says, no, that doesn't work. Because if the sign minus stands for strong rejections only, then the Smiley reductio principles, they are invalid. Because, so here's a reminder, Smiley reductio is from the assertion of A, it follows the bottom, therefore A is rejected. But in the very same examples show this. So somebody who has evidence that Homer does not exist can't assert Homer wrote the Iliad. So if you believe Homer did not exist, then asserting Homer wrote the Iliad entails absurdity. And if Smiley reductio is valid, this means that you then can reject Homer wrote the Iliad. But if by reject here you mean strong reject, so evidence for the negation, it follows that you may assert Homer did not write the Iliad. And so you have reasoned from Homer does not exist to Homer did not write the Iliad, which Dickey says is illicit, because this is not a metalinguistic kind of negation. But the idea of focusing on strong rejections is the right one. Because as Luca and I argued in an earlier paper, and I argued in my dissertation, there is a way around this. So bilateralists should concede Dickey's points, like fine, evidence is not what's going on here. But there's a perfectly fine and equally pragmatic, pragmatistically reasonable way of thinking about inference, and that is the preservation of commitment. And the way we put this in 2017 is that given that a speaker has undertaken certain commitments, inference rules tell us what further commitments that speaker is bound by. And to give you the rundown, this says that when you assert A, this means that you're committing to believing A. So you're putting yourself in a certain social position where you are known as somebody who believes A. If you strongly reject A, then you're committing, Ramseyan, to disbelieving A. So you're making yourself socially known as somebody who would object to A. But if you're weakly rejecting something, then you're making yourself known as somebody who does not, who is not committing to believing A. So you don't ask me why A is true, but you're also not positioning yourself as somebody who disbelieves A, so you're not going to take strong objection to it. And then we can define inference as, so between assertions, for example, if plus A entails plus B, this means that somebody who commits to believing A is socially obliged to concede that they believe A when the issue whether B comes up. And this general idea of thinking about things is very suitable to pragmatism, so it's very close to like a Brandomian way of thinking about assertion. It's just that we have enhanced the Brandomian way to not just associate assertions with commitment, but also associate these other two speech act rejections, weak and strong, with commitment, and then have an inference relation over that. And now we can reassess bilateralism on these commitment preserving terms. So Dickey is still right. Smile reductio for strong rejections is bad, because from committing to believing that A being absurd, it doesn't follow that you must concede to disbelieve A. If it's absurd for you to commit to believing A, you should only withhold commitment. But that's then licensing the weak versions of the smile reductios. So they go as follows. Asserting A and weakly rejecting A is absurd. So you can't at the same time commit and withhold commitment to believing that A. If it is absurd for you to commit to believing A, then you should withhold that commitment. And if it's absurd for you to withhold commitment from A, then you should assert A or commit to believing A. And you might have noticed that I changed my way of speaking here to a normative one. So earlier when I explained these, I explained in terms of what you are entitled to do. And here it's about what you ought to do. And that's because the commitment slate, keeping track of each other's commitments, is the game board of the language game. And sometimes you are forced to make certain moves in that game. And so we have the smile reductio rules being good for weak rejection, but the negation rules, they're only good for strong rejection. Because if you put the O minus here, the weak minus, then these two, this one and this one, they aren't good. Because from withholding assent to A, it shouldn't follow that you assent to not A. So, and this means that the situation is a little bit unsatisfying. So we have half the rules that are good for weak rejections and the other half being good for strong rejections. But it's not terribly unsatisfying. All we have to do is recover a little bit of reductio-like reasoning for the strong rejections. And we already have a strategy for this. So when dealing with the problem pointed out by Dickey, we isolated the evidentially specific instances of rejection, the ones we called strong. And then we say, okay, we just don't do the same thing for these inferences towards absurdity. We say that smile reductio for the strong plus and strong minus is not valid in general, but it's valid for a restricted set of inferences. And indeed, there is nothing wrong with concluding commitment to disbelief towards A from committing believing A being absurd, if that inference towards absurdity is one that preserves this kind of Pravitzian justifying evidence. Because all the issues we had with this were with things that disrupt the flow of evidence. So if we say an inference where evidence flows, if you get absurdity from that, you can just reason as Rumford wanted us all along. And so we can keep restricted versions, that's what the star is for, of the smile reductio principles. So if from expressing commitment towards believing A, you get bottom, and this inference towards bottom preserves evidence, preserves the flow of evidence, then you should strongly reject A. And if from strong rejecting A, bottom follows in a way that preserves the flow of evidence, then you should assert A. But this is not a proof theory, because which inferences are Pravitzian in the sense that they preserve this evidence, that depends a lot on what your language is like. But we can start with a very, very simple language. It's a language of propositional logic. And the only thing that could possibly disrupt the flow of evidence in propositional logic is if you have a weak rejection. As long as you talk about what you believe and what you disbelieve, you have evidence justifying what you believe and evidence justifying what you disbelieve, or evidence where you justify believing a negation, And as long as you stay within that, in the confines of this, there's no way to introduce like a Dickey-like problem. So these rules are valid in that they preserve commitment. So the evidence-preserving inferences are a subset of the commitment-preserving inferences, and you can have these strong reductios if you just stay within the evidence fragment. And so in the confines of propositional logic, we can then have these starred small reductio. So it remains the case that from asserting and strongly rejecting the same sentence, you get bottom. And if you're using no side premises signed with the weak rejection, in the reductios, you can keep your old versions of the reductios. So basically, because these restrictions mean that when you get bottom, it has to come from here. And then this means you're entitled to use the inverse of this rule. And so we can give what we have achieved now a name. We're calling weak bilateral logic the natural deduction calculus consisting of the negation rules for bilateralism, the conjunction rules we inherit from Ian Rumford, the smile reductio principles for the weak rejection, and these restricted smile reductio principles for the strong rejections. Then we can prove a neat little theorem, namely that the logic of assertion is classical. So if you have some premises gamma entailing classically that A, then you can derive, thank you, Marcus, then you can derive the assertion of A from the assertion of all the premises. So we have the Begriffsschrift recovered in pragmatist acceptable terms and implemented the pragmatist insight on negation. And it is beyond on that background that we are now going to talk about truth. Yes, because as you might sense, there's going to be some liar paradoxes around. But first, the first step is very easy. So the observation was truth is to endorsement like negation is to rejection. And well, what speech act is the one that you use to endorse things? Well, that's assertion. And so here's the meaning of truth, T in and T out. From the assertion that A, you then are obliged to accept that A is true, or obliged to commit that you believe that A is true. And if you are committing to believing that A is true, then you're obliged to concede that that you believe A. And that's it. We say these are just the meaning conferring rules. And we call this view inferential deflationism. And inferential deflationism is to explain the truth rules, to explain the meaning of truth by rules that relate the truth predicate to assertion. And there's a subtle difference, but a very important difference to the received view. The received view is that the meaning of the truth predicate just is the expression of endorsement, whereas here the idea is that the meaning of the truth predicate is inferentially explained by its relation to the expression of endorsement, which is assertion. And by doing this move, you avoid the Frege problem. But indeed, not just that, as I will point out. Now, this is just the first benefit that we immediately get from being pragmatists. And so here's the problem we're going to solve: the liar. So this can't be the whole story, because just as with the negations and Dickey, we now have here problems with evidence. Because once we have the truth rules, we get liars. And so the arguments, I'm not going to go through them in detail, they are familiar. We can show that asserting the liar entails asserting the negation of the liar, and we have that asserting the negation of the liar entails the liar by the usual arguments. And of course, that immediately entails that asserting the liar entails bottom. And then by smile reductio, we can conclude the strong rejection of the liar, but that entails the assertion of the negation of the liar, which entails the liar, which entails bottom. So we have the liar paradox in its very, very usual form. So because our logic is classical, hidden behind the assertion sign, there's always a middle somewhere in there, but it's just a regular proof. But we can offer a new diagnosis of this proof. So consider the following three assumptions. First assumption being that these two inferences we have demonstrated from L to not L and from not L to L, they preserve evidence. Second assumption is that it is possible at all to possess evidence for either L or for not L. And the third assumption is that negation, as Price taught us, is used to register incompatibilities. And these three assumptions are incompatible, and you don't need my whole logic here to see that they are, because the first assumption means evidence for L is evidence for not L. The second then means that it is possible to have the same package of evidence supporting both L and not L. But that contradicts three. So if negation should register incompatibilities, you can't provide the same evidence for something and its negation. And so the idea is, if this is the right diagnosis, then avoiding the liar means to drop one of these. And two options have been explored. So dropping the second assumption is the paracomplete solution, dropping the third assumption is the paraconsistent solution, and dropping one is the solution I'm going to expound here. So, and I think it's the best option. So deny that the truth rules preserve evidence, because there's independent reason to believe that they don't preserve evidence. And so here's a little scenario to make this more plausible. So this is about my friend Thomas. So suppose you know that Thomas habitually writes a true sentence on his whiteboard. And perhaps today in Amsterdam it's raining. So today in Amsterdam he wrote, "It is raining" on the whiteboard, but you don't know that. But you know about Thomas's habits. So you will assert to somebody, there's a sentence written on Thomas's whiteboard and it is true. And you have evidence for that sentence from Thomas's habits, but you don't have evidence for "it is raining," because you couldn't justify an assertion for "it is raining" from Thomas's habit of writing true sentences, because you don't know which sentence he wrote. But you're still committed to "it is raining" in the social sense, because all the material facts, once they come to be known, then you are socially obliged to concede that it is raining. And so the inference from the sentence on Thomas's whiteboard is true to "it is raining" is the instance of the T-out rule. And we have seen now here that the T-out rule does not preserve evidence, but it preserves commitment, so it's valid. This argument, when we first see it, is very confusing. So I'm going to go through a formalish version of it. So just let Gödel corner W be a name for the sentence W on Thomas's whiteboard. Somebody familiar with Thomas's habits may justifiably assert W is true, but as I just explained, they may not have evidence for W, because they may not be able to justify asserting the particular sentence denoted by W, because all they know about is Thomas's habits, not what's right now on his whiteboard. But the particular sentence denoted by W just is W, so they may not be able to justify asserting W. So the T-out inference from T name for W to W fails to preserve evidence. And you can do the same kind of spiel for the T-in rule, because if you have evidence for "it is raining," you don't automatically have evidence for the sentence on Thomas's whiteboard is true. And so this diagnosis leads to a cure, because the liar paradox uses the truth rules under small reductio that's restricted to evidence-preserving inferences. But these rules don't preserve evidence. So if you just exclude the truth rules from reductio, you're not going to get the paradox. And I will provide a model theory to show that. But the same diagnosis and cure indeed will work for all the revenge paradoxes. For example, if you include a rejectability predicate or whatever. We have to make a small addition to deflationism, because the deflationists, as they come to us, they are unilateralists. They only talk in terms of assertion and endorsement, but it doesn't take much effort to think, once you have included rejection, you can also use the truth predicate to express opposition by rejecting that something is true. So we also need rejected versions of the truth rules, just as we needed rejected versions of the conjunction rules. These don't preserve evidence for the very same reason. And just by putting a little bit of effort into it, once we have opposition and endorsement on equal terms in our logic, we can derive bivalence, which is also what we wanted, because we are classical logicians. Okay, they go into it. And so then the proper version of inferential deflationism has the 4 truth rules for plus and for minus. And we have these versions of the restricted reductios, where when you assert from the assertion A, you get bottom, you are obliged to concede the disbelieving A. And if from disbelieving A, it follows bottom, you are obliged to concede believing A, if and only if The inference to bottom uses no premises signed with weak rejection markers and also no truth rules. And now let's just call the system extending WBL with the 4 truth rules and these reductios, replacing the old ones, WBLT. And WBLT, obviously, I'm going to say, preserves the result that the classical canons are respected, so the Frege and Begriffsschrift canons of reasoning, because all substitution instances of classically valid arguments are derivable. And the nice thing is we have the classical canons of reasoning. We have put no restrictions on when you're allowed to use T in and T out, but the liar paradox doesn't happen. And so just for the last 15 minutes that I have, I'm going to make it 20 minutes that I have, I'm going to talk about the connection to supervaluationism, because that is not just a model theory, there's a very deep result in here. I take it that this is not universally known, so I'm going to go over very quickly what supervaluationism about truth means. And it's an idea by Kripke. So you begin by taking the standard model of arithmetic, the natural numbers, and just define the satisfaction of arithmetical sentences as usual. And then you want to extend that usual satisfaction to a truth predicate. What you do is you take any set of codes tau, and then say the standard model n and the set of codes tau make true that the code A is true if and only if the code A is in tau. And that is just a definition of what the predicate T means. It does not yet amount to anything we can recognize as truth, because you can just throw any set of sentences tau on there. But Kripke provided us with a method to determine an extension of like a set tau that looks like it could be really truth as follows. You start with the base case, sigma 0, nothing is true, and then you add truths incrementally. And how you do this is in the successor step, you say a code A, so code bracket A is in sigma alpha plus 1, if and only if for all supersets of the previous step, sigma alpha, with the following property, they all agree that A is true. And the property is a kind of consistency property. So there shouldn't be any A in tau where we already know that the negation is true. And then in the limit you sum up. So the idea here is you start with nothing is true, and then you build up the truths incrementally. And what you do is you check all possible candidates for an extension of the truth predicate that are in some sense consistent with what you already know. They should not make something true of which you already know that the negation is true. That's this condition. And then, well, if all possible candidates that are consistent with what you already know to be true, if they all agree that something should be the case, well, then you know, oh, if all possible candidates tell me that this is true, then it's got to be true. So I'm adding this to the sigma alpha plus 1 part of the hierarchy and keep going like this, because I've added then more A's into it. And so there's fewer candidates tau in the next step. And the hope is that eventually you run out of candidates and converge to a single one. And a very simple argument, transfinite pigeonhole argument, shows you that indeed this hope checks out, because there's only finitely many codes for formulas. But with this transfinite induction, we can go all the way up to epsilon 0, and somewhere around epsilon 0. This will just stop because we have gone through all the formulas. And so then this fixed point lambda, where after nothing changes anymore, this is the extension of the truth predicate generated by the van Fraassen hierarchy. This is the van Fraassen hierarchy because Kripke adapted van Fraassen's supervaluation technique. And there's a very deep connection between this and WBLT, but first we need to make WBLT amenable to the standard model of arithmetic. There's just two things we have to do. We have to talk about the quantifiers, and we can just add our usual rules for the universal quantifier, put a plus in front of them, throw them on there, good. And then to characterize the standard model of arithmetic, what we need to do is to add the omega rule. So if we can show about each name for a number that A is true of that name, then we are allowed to introduce that all numbers are A. Call the result QWBL omega T. It reads easier than it writes. And so now we have a logic, a bilateral pragmatist logic about the standard model of arithmetic. And now the result is for all arithmetical formulas, for all formulas in the language of arithmetic extended with a truth predicate, we have that a code for A is a member of the truth extension of the Van Frassen hierarchy, if and only if from true arithmetic we can derive in our logic that plus A. We have that a negation of a code is a member of the extension of the truth predicate, if and only if our logic entails the strong rejection of that formula. And we have that something is not a member if and only if it's weakly rejected. And that means that this logic QWBL omega T axiomatizes the internal logic of the fixed point of the Van Frassen hierarchy. And so this is a model theory for the logic. And since we can show that the fixed point is not empty, we have shown that the truth logic is not contradictory. No liars. You might wonder what the point of this is. So here's one first small point. So Toby Meadows, he once put an argument forward that the supervaluation hierarchies, they are no good for the search for the truth, as long as we can't agree on which hierarchy we should use. Because if we go back in the hierarchy, we have this condition star to ensure consistency. You can, of course, imagine many other ways of ensuring consistency here. So how do you decide on which condition star? Well, if a completely independently motivated pragmatist version of deflationism gives you this exact hierarchy, maybe that's a good idea to prefer this hierarchy. We'll see another hierarchy in a second. I was very ambitious when I prepared this, so I put you the proofs here, but I'm going to skip that. They are clever, but not very insightful. So I'm just moving on to a different kind of hierarchy. So to follow up on the Meadows point here, indeed, one perhaps equally good way of going about the supervaluation hierarchy has been proposed by Andrea Cantini, where you have a different kind of consistency condition. So the Van Frassen hierarchy, the consistency condition was that nothing should be made true that we already recognize to be false. That's a good idea. But Cantini said, how about we just let the taus, the candidate for truth, just be consistent on their own terms. So we supervaluate over all possible tau that only contain either A or A's negation and never both. And if you do this, again, this converges by a pigeonhole argument, you get a fixed point sigma C, and it contains somewhat more truths than the Van Frassen hierarchy. It's a bigger extension. And if you like this hierarchy, you can pursue an extension of QWBLT and just add this rule here at C for Cantini, which means that from not A is true, you get, it's not the case that A is true. And if you allow that this rule be used in evidence preserving contexts, so it's allowed in small reductio, then you get again a completeness theorem, much the same way as before, so that QWBLTC omega axiomatizes the internal logic of the Cantini hierarchy. So why care about this? So it seems that I've now undermined my earlier point about responding to Meadows. I still think, just in terms of simplicity, the Van Frassen hierarchy is the winner here, because the immediate implementation of pragmatism gives you the Van Frassen hierarchy. But if you are more interested in logical matters, this extension to Cantini's hierarchy should interest you for the following technical reasons. So Kripke had a different kind of theory of truth in mind, and Solomon Pfefferman, he provided an axiomatization of that theory in really a monumentally fantastic effort that's called KF for Kripke-Pfefferman. But he implemented the axioms for Kripke-Pfefferman in classical logic. And now there are theorems of classical logic whose truth doesn't follow from KF. And so KF is in a very weird spot, because it itself is unsound for its own truth definition. So something has gone wrong here. And in an equally fantastic effort, Halbach and Horsten, they gave the theory PKF, partial Kripke-Feferman, to fix this. So partial Kripke-Feferman is sound and complete, I think, for its own definition of truth. And something like PKF has not been found for supervaluational hierarchies, and then Halbach and Horsten always say, like, this is why it's better than the supervaluational hierarchies. And what we have achieved on the previous slide and then with Van Frassen hierarchy is something like PKF. It's an axiomatization of the internal logic of these hierarchies, but we have the omega rule in there and we have true arithmetic, and it's all a bit annoying. And so the question is, can we maybe provide a non-infinitary axiomatization of a substantial fragment of these hierarchies? And we can. And the way there is by considering another problem for truth and supervaluationism pointed out by Hartree Field. So, and that's, you will see this is very related to the Halbach-Horsten point. So Field's problem is that supervaluationism is insufficiently compositional, because for the Van Frassen hierarchy, for example, we have that A and B is in the extension of the truth predicate if and only if A is in the extension and B is in the extension, but we don't have the biconditional stating that itself in the object language being a member of the extension of the truth predicate. And this also is a kind of unsoundness. So externally, it is true that A and B is true if and only if A is true and B is true, but then internally, it's not true that the biconditional true of A and B if and only if true of A and true of B. So again, you have a kind of unsoundness here. And then, of course, because we have proven completeness, the very same objection then applies to QWBL omega t, because indeed A and B is derivable from a set of premises if and only if these two are derivable, but this biconditional with the embedded truth predicate is not derivable. But the new perspective we have taken with evidence and commitment really helps here, because Field demands that these conditionals are expressed as material biconditionals. And that is just too much to ask. Because according to our logic, if you assert if A then B materially, so if you assert not A or B, then that expresses that you are permitted to reason from A to B while preserving evidence. Simply because modus ponens is an evidence preserving rule for materials. And the truth rules don't preserve evidence. So although the truth of a conjunction is equivalent to the truth of both conjuncts, that is not a material equivalence, because to show this equivalence, you need to eliminate and introduce the truth predicate, and then you have broken the chain of the flow of evidence. And so asking for material conditionals, if we are right about this evidence business, is just too much to ask. So this is not unsoundness, what Field is pointing out here. What Field is pointing out here is just that something that is not true is not a theorem, and we are perfectly happy with that. But nevertheless, you might want to have embedded conditionals to express these axioms. Well, if you insist, we can bring this to you. So consider the following conditional. So it's introduced by the conditional proof rule. It's eliminated by modus ponens, but we say that the elimination rule does not preserve evidence. And if we say that, then this double stroke conditional is the commitment preserving conditional. It expresses that reasoning from A to B is commitment preserving, but not necessarily evidence preserving. So it's weaker than the material. And well, if we have that, if we expand our logic with this conditional, then we can immediately address Field's concern. Maybe we can derive all of these statements for compositionality. So not A is true if and only if it's not true that A, commitment preservingly, and the same for conjunction, and in the context of arithmetic, then also for the quantifiers. And with this condition in place, we can also then take a few steps towards Halbach and Horsten's question about how to axiomatize Van Frassen's truth. You can axiomatize it as follows. So for all atomic sentences, we can then define that they are true if and only if they are true for atoms. The atomic truth predicate is definable in arithmetic. For all other sentences, they are not true if their negation is true. For all pairs of sentences, you have that their conjunction is true if and only if they're individually true. And for all sentences that have the shape of a quantifier or they have a free variable, all instances are true if and only if the universal statement is true. And so this collection of axioms here, recursive definition of truth, that is the analog of PKF for the von Frassen hierarchy. This is an axiomatization, sound in its own logic, sound according to its own truth, that axiomatizes a substantial fragment of the von Frassen hierarchy. Now, unfortunately, I can't say you which fragment that is, because to run the hierarchy on the language containing this double stroke conditional, what I would have to do is I would have to give a model theory of what it means for this commitment preserving conditional to be true in the standard model of arithmetic. And the standard model doesn't provide that. So this is really a proof theoretic axiomatic approach. But I can tell you that if you axiomatize this, if you axiomatize it like this, then in the double stroke conditional free fragment of the language, that's going to be exactly the von Frassen hierarchy, again, by the previous theorem. And if you want to axiomatize Cantini's hierarchy, well, you just need to add one more axiom for the rule C. Okay, to sum up, I dropped a lot of things on you today. I hope it was interesting, and here are the main takeaways. So what we have done is we have compared pragmatism about truth and pragmatism about negation. We have put them on the same, I think, solid principled basis, avoiding the Frege problem and giving true due to the insight that truth is for endorsement and negation is for rejection. And in that process, I mean, you can believe me, this, we didn't intend that, we chanced upon these tools to axiomatize supervaluationism about truth. And all around that means I truly think we have escaped Tarski's undefinability theorem. Because this theorem, if you read it in like a textbook, the interpretation of the undefinability theorem is that it shows that any language containing enough arithmetic can't express its own truth predicate. So enough arithmetic being enough for the diagonal lemma, right? But this theorem, we can now recognize, this only holds if by expressing your own truth predicate, you mean validating all of the material biconditionals of the disquotational scheme. But if you have the commitment preserving biconditionals, nothing bad happens. You just get the von Frassen hierarchy, and the liars are both weakly, the liar and its negation are both weakly rejected. And so if you want to be a classical logician, if you want to have classical arithmetic, if you want to have Gödel and the diagonal lemma and all of these things, and you still want truth, what you should be doing is using the commitment preserving conditionals, be a pragmatist, and you get to keep all of your classical arguments and the logic of assertion as classical. And that's the takeaway from today. Thank you all so much for coming and for listening. I appreciate it.